In a research which is destined to rank as one of the dozen most brilliant in conception, skillful in execution, and illuminating in results in the history of science, a young man but 26 years old threw open the doors through which we can now glimpse the subatomic world with a definiteness and certainty never even dreamed of before. This was said by Robert Millikan, an American physicist who later went on to receive a Nobel Prize for his work in physics, describing Henry Moseley. Henry Moseley was a profound physicist whose contributions to the scientific world changed physics and chemistry forever and still impact the scientific community today.
Henry Moseley was born on November 23, 1887 in Weymouth, United Kingdom. Growing up, Moseley had always been surrounded by science, especially with his father, a professor of anatomy and physiology, and his mother, the daughter of a barrister who changed careers to become a mollusk biologist. Also, his family was wealthy, so they were able to send Henry to a private school where he eventually earned a scholarship to Eton College. However, after spending time with his studies, there he found the physics lessons were too easy, so he decided to work independently on his studies at only the age of 18. Henry Moseley received an Eton College physics and chemistry prizes for his academic success. In 1906, he was admitted to the University of Oxford's Trinity College, where he studied physics. Moseley graduated with second-class honors in physics.
1910, Moseley moved to the University of Manchester to join Ernest Rutherford's research group. At the time, Ernest Rutherford was a big deal in the science world and a profound researcher. At Manchester, Moseley taught physics and carried out research work, but soon discovered that he did not enjoy teaching as his side job. After a year at Manchester, Rutherford offered Moseley a research fellowship position, and he happily accepted. Rutherford assigned Moseley to work with radioactive chemical elements. Moseley quickly became familiar with the substances and started going beyond just the experiments others had thought of and came up with his own twists, which led to his discoveries.
Before Moseley created his version of the periodic table of elements, elements were organized by atomic mass and were moved around by scientists as needed if there were any inconsistencies.
Moseley worked along with Rutherford and began to become familiar with radioactive chemical elements. He created the first atomic battery, but this isn't his most important discovery. The most important thing is that he discovered that each element emits X-rays at a unique frequency. This meant that he discovered that each element had a different number of protons. The number of protons had defined the elements. An example is that hydrogen has 1 proton and oxygen has 8 protons. This is how Moseley arranged the elements on the periodic table, by atomic number. This made it a lot easier to read and find elements, which was a huge discovery. He was also able to predict the elements not found yet because of the gaps in the periodic table. He was able to predict that there would be elements with 43, 61, 72, and 75 protons. These elements would later be found. Finally, Moseley discovered a non-destructive method to find which elements are in a sample. He used high-energy electrons to look at X-ray frequencies.
Moseley created the periodic table we still use today. He also predicted the 4 missing elements that were found in the next 20 years. Moseley also studied the concept of nuclear batteries with the beta cell, which was researched more and put to use in the 1950s and 60s.
Unfortunately, Moseley did not decide to pursue his studies even though Rutherford and Bragg recommended him to the University of Oxford to be chair of physics. Instead, he enlisted as a volunteer in the British Army's Royal Engineers during World War I. Lieutenant Henry Moseley later was killed in battle at the age of 27 in Gallipoli, Turkey on August 10, 1915. Rutherford was outraged at the news and lobbied to pass a law that stated that no scientist could serve in the front lines. The British government later did close the ban and still is in place today. 1916, the Nobel Prize awarded no physics or chemistry. However, it is said that if Henry Moseley had been alive, they would have gone to him and his work.
His work allowed for the identification of new elements, allowed subsequent researchers to be able to make groundbreaking discoveries about the composition of our world. The impacts of his work allowed for societies to discover elements not found and to be able to predict reactions of substances in society. Also, with the new method, scientists didn't have to do a bunch of expensive experiments and guess compared to Moseley's process of identification, which just looked at the characteristics. By not guessing, experiments went much faster and cost less. The X-ray spectroscopy Moseley perfected is now used in laboratories all over the world.